In this topic, we'll talk about loading databases into the content panel, be they geographical databases or simple alphanumeric data tables. In ArcGIS, to add databases to the content panel, use the map Add Data command. This command allows you to insert a variety of data stored on your computer or a data server, such as buildings and roads. We can also add the base maps provided by the ArcGIS online server, such as aerial images. Streets. Or a topographic map, among others. You can also load other geographical data provided by the ArcGIS online server, such as postcodes, or the 2021 censuses at the subsection level. In addition to these, it is possible to load data tables, that is, databases without a geographical component. In other words, databases which, when loaded, are not accompanied by any graphic display. These and other options are gathered in the lower sensitivity area of the Add Data command. If you notice, this icon has two areas of sensitivity. One corresponds to the More icon over the yellow folder, and the other area of sensitivity corresponds to the area where the Add Data inscription is. Click on the upper area to add the data itself. By clicking on the lower area, in addition to the tool we saw earlier, we also have the possibility of adding data from a known address, tables, or elevation surfaces, among others. Focusing now on the loaded layers, we see that these databases are made up of lines in the case of roads, and polygons in the case of buildings. Both lines and polygons are described by vertices, whose positions are known through their coordinates. So that you can realize this, I'm going to edit their vertices. The small green squares you see are the vertices of the selected road, and at the bottom of the Modify Features panel, you can see their coordinates. You can even check the coordinates of a given vertex. And change their values using the keyboard or graphically. To avoid these changes, I'm cancelling the editing operations. Since they are described by vectors, databases of this type are called vector models. In addition to these, there are other databases. This is the case with the database I'm about to upload. For the sake of the legibility of the view, let's make a change to the symbology. The image we see is a combination of the three databases loaded into the content panel. If we switch off the visualization of the vector model databases, buildings and roads, we can see the entire ortho photo. When we zoom in on the image, we see that the ortho photo layer is made up of small squares, which correspond to different colors. Zooming in again, we can see these squares more clearly. These squares are called pixels, and databases made up of pixels are called raster databases and are commonly known as images or rasters. So, we have vector model databases, described using vectors, and raster model databases, described using pixels. In addition to the characteristics that have already been discussed, others should be clarified, such as those relating to attributes. In the case of vector model databases, in addition to the geographical component that corresponds to the display, there are one or more associated tables where their attributes can be stored. For example, in the case of motorways, we only have a classification by their type: road, slip road, or dirt road. But we could have other attributes, such as the width of the road, the type of surface, or the state of repair, among others. Similarly, in the case of buildings, we can see that each one is identified by the values of the ID_edif attribute, and that the respective area in square meters is known for each one. On the other hand, in the case of raster databases, each pixel has only one attribute. This attribute is always numeric and is translated graphically into a given color. Depending on the numerical value, the respective attribute table may or may not be opened. This table is only available in cases where the attribute consists of integer values, which is not the case here. In addition to this difference in attributes, the databases of these models have another distinctive feature, which is the quality of the display. At the current scale, all the layers present a perfectly perceptible image of good quality. As we zoom in and move to progressively larger and more detailed scales, we find that the quality of the raster model layer degrades and may no longer be intelligible. In contrast, the quality of the definition of the geometric boundaries of the layers in the vector model is maintained, regardless of the scale at which they are visualized. The last aspect I want to address about the two models concerns their use. Vector model databases are particularly well suited to representing variables that can be described by discrete and well-defined values, such as the position of a point where the air temperature is measured, the perfectly defined boundary of the carriageway, or the boundary of a property. By concisely defining boundaries, they are also particularly well suited to determining lengths, perimeters, and areas, as we'll see later. In contrast, raster databases are particularly well suited to describing continuous variables, which can take on any value between a minimum and a maximum. For example, a temperature map of a given area, for which each pixel can take on any real value between the minimum and maximum temperatures. Raster model databases are also handy in map algebra, that is, if we want to analyze the effect of a series of factors for a given area, through arithmetic operations between the maps of these factors, we will probably use raster model databases of these factors to perform these arithmetic operations. To complete this first part of the topic, we need to talk about loading tables. In the demonstration, we'll use an Excel table made up of 3 columns, which contains the centroids of the buildings we saw earlier. The first column corresponds to the numerical identifier of each building. The second and third columns correspond to the x and y coordinates of the centroids, or geometric center of each building, expressed in the Hayford-Gauss system of datum 73. Also, note that the table containing the data is called centroids edificios. Close the table and return to ArcGIS. Tables can be added, just like any other topic, using the Add Data tool. Pointing to the Excel file and selecting the desired table, centroids edificios. Alternatively, in the case of an Excel table, you can use the Excel to Table tool in the toolbox. As it is a table, this database has no geographical component, that is, when you load it, no objects are visualized in the view, but you can see the contents of the table using the Open command. As we saw earlier in Excel, the table is made up of the following columns: building identifier, x coordinate, and y coordinate of the centroids in the Hayford-Gauss system of datum 73. The tables are loaded into the standalone tables group and are positioned at the bottom of the content panel. Once the table has been loaded, we can create its geographical component, as long as the table's content contains information that allows this. To do this, execute the Display XY Data command. In the window opened by this command, we must identify the layer to be created. The columns of the x and y coordinates, and possibly z if we are dealing with 3D data. In this case, as I took care to include the terms x and y at the beginning of each column, ArcGIS automatically identifies them. Otherwise, you'd have to identify the respective columns. To conclude, if it has not been configured automatically, the system in which the coordinates are expressed must be identified. As you can see, it is good policy to include a system abbreviation in the designation of the coordinate columns, so that you always know which system they are expressed in. In this case, it's the Hayford-Gauss system of datum 73, which internally is known as datum 73 Hayford-Gauss IPCC. The points displayed correspond to the layer that was created from the table. To summarize, to load the table we carried out two steps in sequence. The first step consisted of loading the table using one of the Add Data or Excel to Table commands. And the second step was to create the geographical component using the Display XY Data command. However, there is an alternative that performs both steps at once. This is the Add Data XY Point Data command. Running this command opens a window identical to the previous one, where you can identify the table, the layer to be created, the columns with the coordinates of the points, and the corresponding coordinate system. The result, as you can see, is the same. It is also possible to establish links between tables and layers, as long as both have a key field that allows this link, but we'll deal with these later. That's all for now. See you soon.